What is up, mathletes? Welcome back to another episode of Math with Dr. Math. And who was that guy? We're going to be talking to you about combining like terms. Get some. All right, so let's get talking about combining these like terms. But we can't start without you liking this video and subscribing. So let's do this. All right, so let's talk about combining like terms. So before we actually do so, let's make sure you actually know what a like term is, so you don't end up like this guy. All right, so here's some examples, and what you're gonna see is on our left-hand side, we have a bunch of examples of like terms. So 3 and the 2, notice both of these have an x, so they're like terms. Both of these have an x squared. These are like terms. Both of these have x raised to the 21st power. And if we look on this side of examples that are not like terms, we're gonna see this one has an x, this one doesn't. This one has an x squared, this only has an x. This one has an x squared, this one has an x cubed. This has x to the 23rd, this has x to the 21st. So in your notes, when you're writing this down, and what you're looking for when you're talking about the like terms is they have to have the same variable or variables, right? So that just means the same letter or letters. And those variables, right, those bases, they have to have the same exact exponent. So if this x has an exponent of 2, this x better have an exponent of 2. They have to be exactly the same. And that's what we're talking about when we're talking about like terms. So write that down, make sure you understand it, because you cannot move on until you understand that key idea right there. All right, so let's dive in here with some examples. But before we dive in here, check out the math gear, the Dr. Math gear that's coming. What you guys think? Comment down below, yay or nay, right? So we're just playing around with some shirt designs, and let us know what you think. You got the sleeves hugging the guns. What you guys think? Is this a yay or a nay? Let us know, because we want to get this gear out to you. All right, so number 1 here. We got 5q plus 5q. So number 1, are they like terms? Can we combine them? And the answer is yes, right? Same variable, same exponent. So 5q plus 5q equals 10q. You're welcome. How you like what I did there? 10q. Hit rewind, watch that again. You'll get it, you'll get it. All right, next example. We have 3xy plus 5xy. So what you're gonna see that we can do with like terms is that we're allowed to add like terms and we're allowed to subtract like terms. Go ahead, go tell some friends. All right, I know some exciting things right there. So again, like terms, you could add them and you could subtract them. So here we do have like terms, so let's add them. Please do not listen to those bad friends that are gonna tell you to go ahead and change it to x squared and y squared. Ignore them, all right? Ignore them. They didn't come to class today. All you're gonna be doing is you're gonna be adding and subtracting those leading coefficients, those numbers in front. That's all you're working with. So 3 plus 5, that's what gives us the 8. But the variables, you leave them alone, right? They didn't do nothing to you. Leave them alone. All right, that's how we roll in Dr. Math Studios. All right, last one for this page, then we'll hit some other ideas here. So 3pu minus 2pu, all right? So again, you ask yourself, are those like terms? And again, the order doesn't matter. What do you mean, Dr. Math, the order doesn't matter? So if I were to say 3up minus 2pu, as long as they both have a p and a u, the order doesn't matter. They're like terms, right? Write that down. This is gold. I can't be giving you all my secrets. So what we're left with is 1pu. And I already know someone's in the back raising their hand. Do I have to put that one? No, you don't. No, you don't, Jimmy, right? So you could have also wrote just pu. Absolutely fine. Well, we're on the roll, so let's continue with this party. So we have 3x plus 4xy. Number one, are they like terms? No, so you cannot add them or subtract them. So there's nothing for us to do here. There's nothing to see here. Move on, move on. So we cannot do anything. All right, let's look at this next example. You have 3x plus 4xy plus 7x. All of these are not like terms, but if you take a deeper look here, that 3x and that 7x, they are like terms. So what we're gonna do is we're gonna do a little razzle dazzle, and we're gonna rearrange things because we have some mathematical properties, that those commutative properties, that allow us to change the order. And so these two statements right here, these expressions, are exactly the same. They mean exactly the same thing. But all we did is we moved the x's. Oops, I don't know why I did that. Let me bring that back in here. Let me do a little undo. We put the x's next to each other. In real life, in person, I would never do this, right? You would never bring one of your x's next to another x. You're just asking for trouble. But in math is weird, right? It just works better that way. So since our x's are next to each other, let's combine those like terms and tell them what they have, Dr. Math. So you got 10x, and then notice the 4xy is not a like term. So just drop that mother sucker, and that's what we got, folks. All right, let's do some more examples. All right, mathletes, we made it. And if you made it this far, then you better have subscribed and liked this video. All right, so now what we're looking at is, well, Dr. Math, what happens when we have fractions? The rules do not change just because you have fractions, right? This is where you start getting a lot of people making up all kinds of math, right? The rules never change. So all your variables that are the same, write them next to each other. So the 2x over 7, right? And that 3/7 x, we're gonna write those next to each other because they both have an x variable. And that negative 2/3, you're gonna drop that off to the side because it doesn't have a like term. So I know you have fractions here, but just because you have fractions, that doesn't change the rules. So don't start making things up. So we're gonna combine these, and notice they already have the same denominator. So let's go ahead and add those numerators. So what do we get? So we get 5 over 7x. Remember that x doesn't change. And then we're gonna drop down that minus 2/3. And then you're asking, well, what else can I do, right? There's nothing else you can do. So that's how you know that you're finished. All right, folks, so hopefully this video was very helpful. Again, drop us a like, help Dr. Math out. We're trying to grow, reach a bigger audience. And again, let us know what kind of videos you want to see. Peace.